In this lesson, we are going to discuss some more important points about spring block system. We have discussed springs in series where 1 by k is 1 by k1 plus 1 by k2, and springs in parallel where k is equal to k1 plus k2. Now we'll discuss a special case. Here we have got one spring like this, a mass m here and another spring here. Now if we move this mass by a distance x in this direction, now this spring will exert a force in the upward direction because this is getting compressed, and that force is say F2. This upper spring is getting extended, so therefore also it will also exert a force in the upward direction F1. So the force exerted by the two springs are in the same direction. When this mass comes down by x, this spring is getting compressed, so it is exerting a force in the upward direction. This spring is getting extended, so it exerts a force in the upward direction. And this x will be same. If this spring compresses by x, this spring gets extended by x. So now in this case also, the force will get added. F equal to F1 plus F2. So therefore, K equivalent into x will be equal to K1 into x plus K2 into x. So we get K equal to K1 plus K2. So this arrangement behaves like springs in parallel. Here K is equal to K1 plus K2. When this mass m comes down by x, this bottom spring compresses by x and the upper spring extends by x. So therefore the bottom spring exerts force in the upward direction, the top spring also exerts force in the upward direction, and therefore the forces get added, the x is same, and therefore K is equal to K1 plus K2. In all these cases, springs are massless. If the spring has mass ms, so now suppose spring has mass, and that mass, let us call it ms. If a spring has mass, then time period becomes 2 pi root over m plus mass of spring by 3 by k. So 1/3 the mass of the spring gets added to the mass of the block. Now one more situation we can have is when we have two masses, m1 and m2, connected by a spring of spring constant k. If this combination is made to oscillate on a horizontal surface, the time period will be 2 pi root over mu by k, where mu is reduced mass, and that is defined as product of masses by sum of masses. Now, if we cut a spring into two equal parts, spring constant doubles. If we cut a spring into 3 equal parts, spring constant becomes 3 times. If we cut a spring into n equal parts, spring constant becomes n times, as long as each part is a spring. So now, if we have a spring of length L and spring constant K, if this is cut into 2 equal parts, each part will have a length L by 2 and spring constant will become double, that is 2K. And now if these two parts are connected in series, then we have two springs of spring constant 2K connected in series. and the equivalent spring constant of this combination will be given by 1 by k dash equal to 1 by 2k plus 1 by 2k, and that becomes 1 by k because 2k is LCM and 1 plus 1 is 2. So therefore k dash is equal to k. So if a spring is cut into two equal parts and the two equal parts are joined in series, we get back the original spring.